Hi guys, welcome back. So today what we're going to be looking at is we are going to be looking at sketching some parabolas. So we're going to go ahead and describe, interpret and sketch parabolas and some of their transformations. So in this video what we're going to do is we are going to have a look at sketching parabolas by substitution. So we're substituting values into a function. We're going to get a table of values and then we're going to plot those values on a Cartesian plane. Okay, so let's go through. What is a parabola? So a parabola is just the shape that's made by a quadratic function. And a quadratic function is something that has x to the power of 2 as its highest power. So for example, if I was going to write this could be something like x squared plus 3x minus 2, or it could be something like x minus 4 times by 2x plus 3, and then when I expand those brackets out I end up getting x squared as my highest power, or it could simply just be something like x squared on its own. And the highest power of x in every single one of these cases is 2, and so that's what makes it a quadratic function. If it has the highest power is the power of 3, that would be a cubic. If it's to the power of 4, it would be a quartic function. So if the equation of a parabola is given, we can substitute a variety of x values into the equation and plot the resulting coordinates. So for example, let's start off by graphing this very simple function here, x squared. So graph the function of f of x is equal to x squared for the domain from -5, including -5, to +5. So what I've done is I've created my table of values for the specified domain. And since, again, this is including -5 and 5, and I know that because this is less than or equal to, so that means it is including the -5 and the 5, I've gone from -5 all the way up to 5. Okay, so next what we're going to do is we're going to substitute in the values. Now I'll just show you how to do this for one example. So first things first, we're going to write the formula. So the function of x is going to be equal to x squared. We're going to be substituting in -5, and when we do this, you have to be very, very careful to make sure that those brackets are wrapped around that negative sign, because if you put it in your calculator like this, the way that your calculator reads that is as -5 squared like that, and so you'll end up with -25 as your result. That's not actually the case. -5 squared, or -5 times -5, is going to make +25. So just make sure you're very careful about that when you put that in the brackets. And so then I'm going to go ahead and I'm going to do the same thing for each of these, and I'm just going to fill out this table. Okay, so if you're going to do this by hand, this does take a little bit of time. You can do it in Excel as a function and then just click and drag the cell and it will do it like instantaneously. All right, so next thing we're going to do is we're going to plot the x-axis against the y-axis. So we've got all of our points as ordered pairs. So our first point is going to be -5, 25, -4, 16, all the way up to this side of our function. And when I plotted all of those, this was the shape of the graph that I got. So this shape is called a parabola, as we said before. So let's have a go at some of these questions. So plot the graph of each of the following equations. In each case, use the values of x shown as the values in your table. State the equation of the axis of symmetry and the coordinates of the turning point. So let's just talk about what they mean by axis of symmetry. So as you saw before, we've kind of got like this smiley face here. And the really nice thing about this smiley face is that it is symmetrical, right? And in this case here, if we look back at that previous example, it's symmetrical through that x-axis. So in other words, through this axis running down here. At the very bottom here, this is called our turning point. And the reason for that is this is the point where our smile turns over. So we have a negative slope, it's going down, 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 and then it reaches 0, and then it goes positive, positive, positive. So that would be our turning point there. And our turning point is always going to go through the axis of symmetry. Okay. So if you want to have a go at these now, you can pause the video. I'll just quickly show you how to do this if you are interested for question A. And then what I'll do for question B is I'll just show you the value of tables and the resulting graph. So if you want to have a go at A now, pause the video. All right, so let's start off. So first things first, we're going to draw a table. So for this one, I'm going to go insert table, and I'm just going to get a bunch of them there. Now we've got our X and we've got our value for Y. So they're saying that we need to go from -3 to +3. So I'm going to fill out that table. And the next thing it would like me to do, it would like me to find the value of Y. So I'll just show you one example and then I'll go ahead and fill out the table. So first things first, we're going to start off by writing our formula. So y is equal to 3x squared. Next, we're going to substitute in our first value, which is going to be negative 3. Whoops, negative 3. Negative 3 squared is 9. 9 times 3 makes 27. So then I would go ahead and I would fill out the value 27 here. So I'm going to do that for every single one of these x values to get my y coordinates. All right, so I've gone ahead now and I've finished filling out that table. So next what I'm going to do, I'm going to take each of these coordinates and I'm going to plot every single one of these. And then what you'll be able to see is you'll be able to see my parabola function. All right, I think the easiest way for me to show you how to do this is through Excel. So I've just typed my, not Excel, sorry, Desmos. I've just typed my function in up here as well as the restrictions of that particular domain. And then what I've done is I've just plotted each of these points. So these are the points, same points as before, and we can see those there. And we can see that this is making, we can see that this is making a nice round shape. So this is called concave up. I like to call this the happy parabola. All right, so let's go back and let's have a look at this second one now. So the second one now, it's asking me to do a quarter x squared for the same domain. Now for this one, again, I'm not going to actually show you how to do the table because it's basically the same process as before. You just write x from negative 3 to 3 and then you just determine the value of y by substituting into the equation. Then you plot the points on a Cartesian plane. So what I'll do is I'll just show you how to do that now in Desmos. So I'm just going to type this function 1/4 x squared into Desmos and then we'll be able to see the differences between the two. So y is going to be equal to 1/4 x squared. Okay. And what I'm going to do is I'm just going to copy that same domain so that they're restricted to the same domain. All right, so what do we notice about the difference between these two functions? Well, first of all, I would say that this function here, right, this function here is a lot steeper compared to this second function. Or we could say that this second function is a lot flatter. And that all has to do with these coefficients out the front. So this first coefficient that we have is 3x squared. So when we have a large coefficient, it's making this value here quite steep. When we have something that's a fraction, it's making it quite flat. So let's go back and let's have a look at this last question here. So compare the graphs you have drawn for question 1 with that of y is equal to x squared. And explain how placing a number or a coefficient in front of x squared affects the graph obtained. All right, so let's go back here and let's type in that same function now. So y is equal to x squared and let's compare what these functions look like. Well, compared to just x squared, again, this is quite steep, this function, and this here is quite flat. So if I was to make a comment about how placing the number or coefficient in front of x squared affects the graph obtained, I would say that if this value is bigger than 1, then it's making the graph steeper. If this value is a fraction, then it's making the graph flatter. Let's have a go at another couple of questions here. So plot the graph of each of the following values of x between negative 3 and 3. State the equation of the axis of symmetry, the coordinates of the turning point, and the y-intercept for each one. All right, so I'm going to go ahead and I'm going to fill out my table of values for y is equal to x squared plus 1, and then I'll come back. Okay, so I've got my table of values now, so I'm going to go ahead and I'm going to plot those. And again, I've just done this using Desmos, so it'll be a little bit easier and a little bit neater to show you guys. So I'll just pop over to Desmos now. So this is our function that's running through each of those points, and you can see where I've plotted each of those points. So in this case, if I was to compare this, so this is x squared plus 1, if I was to compare this to the graph of x squared, again, you can sort of, oops, sorry, that should be an equal sign. You can sort of see that all we've done by adding 1 is we've just moved this whole curve up one spot, okay? So this number on the end is telling me the vertical translation, so how far I'm moving this up or down. Okay, so let's have a look at what that second part of the question was now. So compare the graphs you have drawn with the graph of y equals x squared. So yes, we've done that. We've seen that it's shifted this graph up by 1. Explain how adding or subtracting to x squared affects from the graph obtained. Okay, well, similarly to before, if I'm adding or subtracting a value on the end here, then that's going to shift that entire graph up or down. Oh, sorry, this question here. State the equation of the axis of symmetry. So if I go back and I have a look at my graph, for y is equal to x squared plus 1. This here is going to be my axis of symmetry. So this is the line that's running down through the middle of that function. And we can see here the turning point at the bottom. So the axis of symmetry is always going to go through that turning point. Now, since this is a vertical line, we know it's going to be x equals to something. And since this is right on the axis, this is going to be x is equal to 0. So if I plot that function in, x is equal to 0, and let's do this in a slightly different color so we can see. Let's do that purple. So we can see that axis of symmetry that's going through that parabola function through that turning point there. Okay. State the coordinates of the turning point and the y-intercept for each one. Okay, so the coordinates of this particular turning point, well, this is the turning point here, so that's going to be at 0, 1. And we saw before when we just had that general function y is equal to x squared that the turning point is going to be at 0, 0. And the last question, I think, was the y-intercept. So this is the point where it crosses the y-axis, or the same as the value when x is equal to 0. So when x is equal to 0, y is equal to 1. So therefore, the coordinates of the turning point in this particular instance are also the same as the coordinates of the y-intercept. And that's because we haven't had any horizontal translation. We've only had vertical translation, so vertical movement up and down. All right, so have a go at the next couple of questions yourself. So create a table of value for the particular domain that they've mentioned, find the y values, plot those as coordinate points. So for example, this first point here would be plotted as -3, 10, and then the next one would be -2, 5, and so on. And then just make sure that you find the equation of the axis of symmetry. Now again, all of these we can see we've just added or subtracted values on the end. So I'm going to have a guess is that it's going to be in a pretty similar spot. And then the coordinates of the turning point and the y-intercept for each one. All right, that one's pretty straightforward. What I want to have a look at next video is I want to start having a look at drawing parabolas straight from the equation. Now you've sort of probably picked up along the way as we've gone here when we've manipulated some of these variables. So for example, the first one that you saw that I manipulated was when we had y was equal to ax squared and the impact of this coefficient and what that did. And then the second one that we sort of have had a very brief look at was what happens when we add a value here on the end. And we know that that's going to start shifting it up or down. So maybe you're going to start piecing together some information about how the transformation of these graphs are going to work just from the equation alone. All right, guys, I'm going to leave it there. I'll talk to you in the next video. Have a lovely day, and I'll talk to you again soon. Bye, guys.